It's the year 452, and the Roman Empire is collapsing. The Huns are tearing through northern Italy, burning cities to the ground and forcing thousands of locals to run for their lives. Desperate to escape the invading armies, these refugees head off the coast and wade out into a massive, shallow saltwater lagoon. They take shelter on a cluster of tiny, isolated islands, putting a natural moat between themselves and the destruction on the mainland. They've traded the threat of the sword for a landscape of soft clay and salt water. In this sanctuary, there are no fresh springs, no solid roads, and the ground itself is so unstable it can barely support the weight of a person. This settlement began as a desperate struggle for survival, yet it forced a transformation of the marsh into a central hub for European commerce. Every building and every canal became a calculated engineering solution to the lagoon's unique demands. If you're going to build a sprawling metropolis, a sinking mudflat is the worst starting point. To hold up thousands of heavy stone and brick buildings, the Venetians first had to invent a solid foundation. They sailed across the Adriatic to the forests of Croatia, harvested massive timber logs, and brought them back to the lagoon. Then they hammered these tree trunks straight into the muck, driving them about 5 meters down until they finally hit a much harder layer of solid clay. A single log isn't enough to hold a building. By packing thousands of these piles incredibly close together, they physically compressed the surrounding mud. The sheer force squeezed the water out of the clay, turning a soft swamp into a rigid, highly stable base. Once an entire cluster was firmly in the ground, they leveled off the tops. They laid thick wooden planks horizontally across the logs to spread the load evenly, and then stacked heavy blocks of waterproof Istrian stone right on top, raising the foundation above the waterline. Because these wooden piles are completely submerged in mud and salt water, no oxygen can reach them. Without oxygen, bacteria cannot survive, making it physically impossible for the wood to rot. Venice owes its entire existence to a hidden underground forest. With the sub-foundation secure, they could start building upwards. Initially, they built houses out of wood, but after a string of devastating fires, they switched over to brick. Since the ground beneath them was still technically a shifting mudflat, they kept the weight down by strictly limiting buildings to 3 stories high. Instead of using rigid cement, builders opted for lime mortar. Lime is inherently flexible. When the clay base inevitably settled and shifted, the lime allowed the brick walls to sway and stretch slightly without cracking apart. Inside, they constructed the interior walls in a crisscross pattern. This allowed the entire skeleton of the house to act like a flexible wooden trellis, constantly yielding to the subtle movements of the earth. The problem was the front of the buildings. These heavy stone facades featured large, elegant windows, making them prone to leaning and collapsing forward into the canals. To counter this, builders ran heavy iron rods through the structure, pinning the front walls securely back into the floorboards. The architecture of this city works because the Venetians engineered structures that could yield and move with the mud, rather than attempting to resist the environment with rigid strength. As these highly specialized island communities thrived, they slowly expanded outwards. In the early days, crossing from one island to the next meant hopping in a boat, or if the water was shallow enough, wading a horse through the lagoon. Eventually, a booming population demanded permanent connections to the financial center. They engineered a massive stone crossing, the Rialto Bridge. To support the enormous weight of this single arch, they drove 12,000 timber piles deep into the banks of the canal. Following the success of the Rialto, stone bridges popped up everywhere. This tied hundreds of isolated islands into a single, compact urban block carved entirely by water. This created a massive logistical advantage. Venice developed 2 completely independent transport networks. All the commercial freight and heavy goods flowed effortlessly through the canals, while pedestrians moved freely along the elevated walkways above. There were no carts clogging the streets or overlapping traffic jams slowing things down. This frictionless dual network allowed Venice to process and move vast amounts of trade faster and more efficiently than anywhere else in Europe. By the 16th century, the city had swelled to 170,000 people. But being surrounded by the sea meant every single drop of water around them was incredibly salty and entirely undrinkable. Relying on boat deliveries from the mainland wasn't enough to keep the population alive, so engineers excavated large areas beneath the city's public squares, lining the deep underground pits with a thick, waterproof layer of clay. They filled these basins with layers of sand and stone, then graded the surface paving tiles to slope inward. When it rained, water poured off the nearby roofs, flowed into the basin, and slowly filtered through the sand and stones until it pooled cleanly in a main vertical shaft at the center. Every square became a giant architectural funnel. This rainwater harvesting system successfully fed more than 600 public wells across the islands. But a massive population also generated an enormous amount of waste. With garbage and raw sewage accumulating in the streets, engineers carved out an intricate network of underground tunnels designed to catch the waste from every building and flush it out to the sea. Instead of relying on manual labor to clear it, they used the ocean. Twice a day, as the tide rose in the lagoon, millions of gallons of seawater forcefully surged into these dark stone corridors. The lagoon's daily tides provided a recurring cleaning force. The moon's gravity pulls salt water through the city to disinfect and flush the entire system twice every day. Today, almost every piece of this intricate medieval machine is still completely intact and fully operational. When you walk through these squares or stand beneath towering stone bells, you are suspended directly over a 1,000-year-old forest of petrified timber, still flawlessly balancing millions of tons of stone above the mud. Venice is far more than a romantic destination. It is a profound example of human adaptability, proving that an environment's greatest challenges can be engineered into its most enduring strengths.